Okay, chapter 9.4, graphs. We've been working on functions this whole time. And we've talked about the function machine, which I've always shown as this little chute where you put something in and something else comes out. And it's just this machine. You can think of it as a metal machine. It's not really made of anything. It's more of an idea. A function is something that does something, like you can add 2 to a number. Any number you put in, add 2, and the sum comes out the other end. And representing a function can be done in several ways. The first way is with words. For instance, you might say you might say each output is 2 more than the input. That's words. Each output is 2 more, and that's what we're talking about here, than the input. Okay, that's one of the things. We have the output, which is this, and we have the input, which is what goes in. If we can put that in an equation, so we have words, then we have equation. And the equation might look like y equals x plus 2, where the x is the input and the y is the output. We could put that together in a chart. Kind of look like this. There's a couple of ways to do it, and we've done it several ways. Okay, and in this chart we have an in, which is an x, and an out, which is the y. And we just start using numbers, like 1 plus 2 is 3. That's what the y is. 2 plus 2 is 4, and 3 plus 2 is 5. Of course, you could also do 10 plus 2 is 12. You don't have to go in order. It's sometimes somewhat logical to go progressively, but you could use 10 as an input and you'd get out 12. You could use 113 as an input and you'd get out 115. We can map it. They use these little boxes in the book to map it. And again, they had an input and an output. Whoops, that didn't work very well. Let's change my tool. An in and an out. And the same thing, they had a 1 going in and a 3 going out, or a 2 going in and a 4 coming out, 3 and 5, and then we did that 10 and 12. All right, and they go directly to each other. They can be written as ordered pairs like this, and then they can be drawn on a graph, which is what we're doing today. See if I can get this graph on here and find a good spot to put it. Okay, and let's see if I can. There we go. So if this is the graph and I want to graph these points, then this is 0. Let's see, maybe I can grab a tool. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like I might have some trouble with the 12. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 12 would be somewhere up here. Now it's not going to be exact, obviously. But if we graph our points, 1 and 3 is right here. This is 1, 3. The next one, 2, 4, is right here. The next one, 3, 5, is right here. And we can see that creates a line. And in fact, if we go up to 10, 12, and it's about here, this would be 10, 12 using this point here. 10, 12. If we connect the dots with a line, I think we should be able to see that it looks like it works pretty well. And a lot of times functions are linear. And all the functions that you're going to do for the next year or two are linear. They make a nice line. Whatever goes in comes out, and there's a proportionality, and they make this line every time, which is actually kind of cool. You're going to see that more often. And we could do this over and over again. This is what you have to do for your assignment. So I guess one more example, and then we'll call it good. They want us to graph, this is the instructions, y equals 2x plus 1. Now this is a function. This time we're going to use a t-chart, which is always my preference. Put the x's here, which is the input, and the y here, which is the output. And just start putting in some numbers. We can put anything we want in. Let's just use regular numbers, 1, 2, and 3. So if we put 1 in, that means y equals 2 times 1 plus 1, which is equal to 2 plus 1, which is equal to 3. So y is equal to 3. If we try the next one, y equals 2 times 2. That's what the next input is 2. That's what the x is, plus 1. And then we can continue to solve. 2 times 2 is 4, plus 1, which is equal to 5. So y is equal to 5. And then one more in pink. Y is 2 times 3, because that's our third x, plus 1. That's the same equation we've been using, is 6 plus 1, which is 7. So y is 7. So y is 7. I forgot to put in with the purple. No. One of those purple ones. 5. Okay. These become the ordered pairs. Let's choose a completely different color. 1, 3. 2, 5, and 3, 7, and we can graph those using our graph paper. Let's move this down here. Maybe I'll try to make it a little big. No, I don't know how to make that bigger, so we just won't. Sometimes it works. Alright, so you always have to kind of start with your numbers. 1, 2, 3, 4, 5. I don't have to go past 3 on the x, but it looks like I have to go all the way up to 7 on the y. And I was hoping to make it bigger so that these wouldn't be so crowded. Alright, 1, 3 is this point right here. And this is the part sometimes we have trouble with. The x-coordinate is first, the y-coordinate is second. The x one is always this horizontal line, and the y is always the vertical line. And so the point 1, 3 starts at 0, 0 and goes over 1 and up 3. So over from 0 to 1 and up from 1, 2, 3. And it matches with this 3 here. The next one is 2, 5, so we go over 2 and up 5. And you can see that we've counted 1, 2, 3, 4, 5 up. We counted 2 over. And the next one is 3, 7. So you go over 1, 2, 3 and up 7. And again, if I take a pencil and a straight edge, I can make a line that crosses through all these. And we can start to predict where the next one is, because you can see that we went up 2 over 1, up 2 over 1. So the next one is supposed to be right here. And then the next one after that would be up here somewhere. And it just keeps going. That's pretty cool, and that's really all there is to it. It's going to be new for a few of you. I understand that. But just get some graph paper from me, watch the video, do the video while you're doing a problem if you need help, or talk with me in class, talk with your friends in class, and just have fun with this assignment.